So, this is the first lecture on relative motion, and we'll try to wind up this chapter in one or maybe maximum in 2 lectures. Relative motion in 1D, we'll try to cover 1D today, and if possible, we'll probably venture into relative motion in 2D and 3D. Anyways, what do you mean by relative motion? That is the first thing that I'm going to ask. Is this something new that we are doing it for the first time, or we have done it before? Or are we doing it for the first time? Or are we hearing the term relative motion for the first time? Yes. What do you understand by relative motion? Huh? Say.
The comparison of motion between two bodies.
Comparison of motion. How do you compare motion? Comparison of motion. How do you compare motion?
With respect to another body. One body with respect to another body.
A body with respect to another body. Were we doing this up till now, or where we were not doing this up till now? Up till now, the whatever we have studied a lot of things: motion under gravity, motion in 1D, projectile motion. Were we studying relative motion or not? We are
Yes,
only studying motion and not relative motion.
Yes, sir. With respect to reference.
Yes, up till now also we were doing relative motion, but whatever motion we were studying, they were with respect to ground or earth. Now, in the very first day, I told you that rest and motion are what type of terms? And the word is rest and motion are relative terms. Do you remember this term? Rest and
Yes,
motion are relative terms. And I told you what do you mean when I say relative. That means it depends on. Rest and motion both depend on what?
Frame of reference.
They depend on the frame of reference or reference frame. So depending on from where I am watching the motion may appear somewhat different. Now, up till now, whatever motion we were studying, they were all with respect to ground frame or earth frame. We can continue doing the same thing. So there is no actual need to study relative motion because we have been studying relative motion from the first day. But all the motion that we were studying were with respect to ground frame or earth frame. Now, what is the need to change our frame and to study the motion in a different reference frame? I'll just give you a small example. Suppose this is plane surface and this is a wedge kept on a plane surface. Let us say the mass of this wedge is capital M. And then I have one more body of mass small m kept on the top of this wedge. Now, if the niche wala wedge does not move, it does not go anywhere, then the motion of the top body is very simple. Yes or no? If this niche wala wedge, the below wedge is fixed, it does not move, then the motion of the block kept on the top is very simple. Yes or no? The block simply moves like this. Yes or no?
Yes, sir.
Whether I watch it from ground or whether I watch it from the top of this wedge, the block just moves down. It is very simple. But things become a little more complicated when the lower block starts to move. Good evening, Shruti. When the lower block starts to move,
Sir, I can't see your screen, sir.
You can't see my screen, sir. Everyone else can see my screen. Now you can see it. Bacha, you can see it now. You can see it now. She has disappeared. Shruti, can you see it now?
No, sir, it's just blank.
It's just blank. So, bache, you can see my screen on the in the classroom? Yes or no?
Sir. Yes, sir.
So Shruti, so you log back, log out, come back. Probably there's something wrong with yours.
Okay, sir.
Log back, go out, come back in. Okay. Now, what was I saying? If the block does not move, the niche wala block, the lower wedge does not move, then the motion of the upper block is very simple. From wherever you look at it, it just goes down like this. But the problem happens when the lower block also starts to move. Now, when the lower block starts to move, and I am sitting on the top of this lower block, so this is the red Hulk, and this is the blue Hulk. So two Hulks, two smiling ones will be good. Two twins who are trying to observe the motion. The first one, the red one, is observing the motion from the top of the wedge. The wedge is also moving, remember. And the second one is observing the same motion from the ground frame. Now, how does the motion appear to both of these? And for which gentleman does the motion appear very simple? Remember, when we are trying to study physics, we are trying to make things simple and not complicate them. So, the red one or the blue one, which one will see a simpler motion? Which twin will see simpler motion? The red one or the blue one? This is red one is red, two is blue. The red one, because he is on the top of the block, to him it will still appear that the block will just move down the plane. But if we talk about this gentleman, for him the motion is very complicated, because he will not just see the block moving down, but he'll also see the wedge moving forward. So for him, the motion becomes very difficult. We can still study the motion from that blue gentleman, but it becomes difficult. And therefore, there is a need to understand this relative motion. We have been doing relative motion, but we have been doing all the motion from the blue gentleman. We were studying all the motion from ground. Now, to make things simple, we might be interested in studying the same motion from a different body, because from that body the motion might look very simple, and that is the need that we need to change sometimes our reference frame. Do we understand this? That is what is meant by relative motion. Relative motion means nothing, but we are studying the motion of one body with respect to some other body. We have been always doing that. Up till now, we were doing it with respect to ground. Here onwards, depending on the case, we might change the reference frame from ground to one body, from ground to the other body, from one body to the other body. Do we understand this?
Yes, sir.
That is all about reference frame and relative motion. Now, if I write equations, how does the motion change with respect to a reference frame? For example, if I write formula number 1, R A B. Now look at the symbols and tell me, what does R vector AB mean? R vector AB means, tell me. R vector AB means, R means position, arrow means vector. So R vector AB means position vector of
A to
A
B.
with respect to B. Do we understand this? Up till now, whenever we were writing the position vector of any body, that position vector was written with respect to ground. So whenever I was writing R vector A, that was with respect to ground. So that now means position vector of A with respect to G. G here means ground. So this is position vector of A with respect to ground. Do we understand this? Similarly, if I write R vector BG, what does that mean?
Position vector of B with respect to ground.
It will mean position vector of B, position vector of B with respect to ground. Up till now, we were simply writing it as R vector. Now we are just introducing R vector AB, R vector AG, R vector BG. Just to specify, just to understand that with respect to which body we are writing the position vector. Position vector of A with respect to B, that means this one simply means, now try to understand the meaning of this. This thing simply means how A appears to be. What is the position of A with respect to B? If I become B, how does A look? Where is A if I am B? Do we understand this? Position vector of A with respect to B simply means if you are B, where is A? Now, there is a relation between these three quantities, one in yellow, all the three in yellow. There is a relation that relates all these three quantities. Can you tell me that relation that relates all these three quantities? What is that relation that relates all these three quantities? And the relation is position vector of A with respect to B will be equal to position vector of A with respect to G minus position vector of B with respect to G. Do we understand this?
Yes, sir.
That is the first formula that comes for us. Now, if I find the change in position vector becomes displacement. So now I can write the second equation, delta R AB. Now, can you tell me what is the meaning of delta R AB? Delta means change. Delta R means change in position vector. Change in position vector means displacement. So displacement of A with respect to B will be equal to what? Displacement of A with respect to B will be equal to displacement of A with respect to ground minus displacement of B with respect to ground. Am I clear or is it getting too confusing? Am I clear? Similarly, now you can write point number 2. And I will just write VAB. And I would ask you, what does VAB will mean now? What does VAB mean?
Velocity of A with respect to B.
And what will be the formula for velocity of A with respect to B?
Velocity of A with respect to ground minus velocity of B with respect to ground.
Velocity of A with respect to ground minus velocity of B with respect to ground. That is as simple as it gets. Then I can also ask you the third formula. What would be the third formula? What I have done is, from equation number 1, I have differentiated it. Position vector, differentiate, becomes velocity. I will differentiate it once more. So what is the third formula that I'll get? acceleration of A with respect to B will be equal to acceleration of A with respect to ground minus acceleration of B with respect to ground. Do we understand this, or this has gone above our head saying bye bye, I'm going, don't stop me? Do we understand this? Yes or no?
Yes, sir. Yes, sir.
Anyone having any doubt? Everyone has written this down. Yes or no? This is a yes, this is a no. Shall we move ahead in life? Now remember, these equations, if I talk about equation number 1, equation number 2, equation number 3, they are all written in vector form, and therefore they are valid for all dimension. Whether it's a motion in 1D, it is valid. Whether it is motion in 2D, it is valid. Whether it is motion in 3D, it is valid. It is also valid if the motion is uniform velocity, uniform acceleration. It is valid everywhere, because these are the definition of relative velocities and relative accelerations. Do we understand this? So these are valid always valid. Do we understand this? No matter
Yes,
what
sir.
type of motion we are studying, whether it is in 1D, 2D, 3D, 5D, uniform, non-uniform, accelerated, variable acceleration, whatever, acceleration of A with respect to B has to be acceleration of A with respect to ground minus acceleration of B with respect to ground. Do we understand this?
Yes, sir.
I hope you have written this. Now let us move on and write equations of motion. And most of the cases where we will use this relative velocity or relative motion, these equations or these questions will be for constant acceleration. Variable acceleration, we can also write this equation, but they normally do not come. So basically, we can write the equations of motion for constant accelerations. What is the first equation of motion that I'm going to write? I'll just write it and then I will expect you to repeat it. V A G is equal to U A G plus A G times T. Do you understand how I've written this equation, and what is the difference between this equation that I have written here and the equation that I wrote in uniform acceleration ka motion? What is the difference? There in that equation that I wrote at first, I did not write AG because we were doing everything from ground. But here, since we are studying relative motion and we might have to change our reference frame, that is why it is good to identify your reference frame and note it down. So now what does VAG mean?
Velocity of A with respect to ground.
V here will be final velocity. We understand this? Final
Yes, sir.
velocity of V of A with respect to ground will be equal to initial velocity of A with respect to ground plus acceleration of A with respect to ground times T. Now can you tell me the second equation? Remember, all these equations are only valid when the acceleration is uniform or constant. What would be the second equation? The second equation will be like this: delta R of A with respect to ground will be equal to U of A with respect to ground into T plus half of acceleration of A with respect to ground into T square. Do we understand this? Nothing has changed, only I've just put ANG. The third equation, which I don't like, is V of A with respect to ground dot V of A with respect to ground. This is how it is written in vector form. I can't change it. Will be equal to U of A with respect to ground dot U of A with respect to ground plus 2 times delta R of A with respect to ground dot product with acceleration of A with respect to ground. I know they are looking complicated, but this is how they are written. Do we understand this? We can also write the equation for V average. V average of velocity of A with respect to ground will be V final velocity plus initial velocity divided by 2. So basically why I'm writing this equation is to make you understand that nothing has changed. These are on the left hand side I've written equation of A with respect to ground. On the right hand side you will have to write the equation of A with respect to B. Can you write the equation of A with respect to B? What will be the first equation? What will be the first equation? Can you write it on your own? Velocity of A with respect to B, final velocity will be equal to initial velocity of A with respect to B plus acceleration of A with respect to B into T. Do we understand this?
Yes, sir.
Can you write the other other three equations on your
We will
own?
write, sir. Yes, sir.
I will give you 2 minutes to write this. I want you to do it on your own so that you have this confidence that they are same. I'll give you 2 minutes and then I will come back 2 minutes. Have you written
Done,
it
sir.
down, Bacha?
Done, sir.
Okay. Now I can write the same equations. Again, obviously for constant acceleration along x and y axis. If the motion is in 1D, I can write only one equation along x axis. If the motion is in the vertical line, only one equation along y axis. If the motion in 2 dimension, one equation along x axis and one equation along y axis. We already know how to do this. Yes or no? Right.
Yes, sir.
Now, whenever we are writing equations in that way, we'll have to use sign convention, and we must always remember what is our sign convention. This direction is taken as positive if the motion is along x-axis, and if the motion is taking in the vertical direction, we will take the upward direction as positive. Yes or no? No, yes.
Yes, sir.
You can write the equation along x or you can
Yes,
write
sir.
the equation along y. We can just simply write the equation, and I'll just quickly go through those equations. So I will write velocity of A with respect to ground will be equal to initial velocity of A with respect to ground plus acceleration of A with respect to ground into T. Equation number 2, displacement of, I'm not writing vector sign because I will use plus and minus. A with respect to ground will be equal to initial velocity of A with respect to ground into T plus half acceleration of A with respect to ground into T square. The third equation is V square of A with respect to ground will be equal to U square of A with respect to ground plus 2 times acceleration of A with respect to ground multiplied by displacement of A with respect to ground. Do we understand how I've written these equations?
Yes, sir.
And I will finish here because I just don't want to spend more time on this. Then similarly, you can write the equation of A with respect to B. Yes or no? The three equations
Yes,
of
sir.
A with respect to B. So I'll give you 2 minutes to write those three equations, and let us not waste more time and quickly move and solve some problems based on this slowly. 2 minutes. Note down the equation. Get confident. In most of the cases, we might not use the vector equation because we might just use equation along x-axis, equation along y-axis, and then solve it. So 2 minutes. Once you are done, please let me know so that we can begin with some question and answers. Have you noted it down, bacha?
Done, sir.
Then, sir, fatafat this question, sir. Look at the question, read it, give me the answer. Don't need to write the question. I think it is from your module itself. So here comes this question. See the figure. Take positive direction towards right. This is the normal positive direction. And negative towards left. Find XAB, XBA, position of only X coordinate we have to find out. X coordinate of B with respect to A, XCA, XCB, XAB, XAC. I hope you can tell me the answer fatafat. I'll give you a minute to think about it. I'll wait for a minute and then I'll ask you your answers. I can make it more bigger if you want to see it. Make it as big as this one. Yes, more big. Yes, do we have answers, my dear friend? Position of B with respect to A. Tell me.
-4.
This direction is positive, my dear friend. So it's position of B minus position of A. It's B with respect to A. Where is B if I am A? If I am A, B is aage on the right of me. So it is not -4, beta. It is +4.
Plus 4.
Do we understand this?
Yes, sir.
Now, whenever we are doing questions on relative motion, for example, it is written B with respect to A, then what do you think? B with respect to A, you become A. Once you become A, you don't go anywhere. Everything comes to you. So, if you become A, you are here. Where is B? B is right of you. Right is positive. So, it is +4. Do we understand this?
Yes, sir.
What about the second answer? C with respect to A. So you become A and then you look at C.
+10.
The answer is +10. Everyone understands this? Meter or whatever. Third one, C with respect to B. So now you have become B. Now
Plus
you are
6.
now you are this gentleman. Yes. Answer is plus
Plus
6.
6.
A with respect to B. So again you are B now. And then you are looking at A.
Minus 4.
Do you see a relation between these two? Do you see a relation between these two green gentlemen? Yes or no? They are
Yes, sir.
opposite of each other, no? Because they are opposite vectors. Yes or no?
Yes, sir.
The last one is
Minus 10.
A with respect to C. So now you have to become this C. And then you look at A, and A is on the left of you. And the answer is minus 10. You can now see the relation between this pink gentleman and this pink gentleman. This is plus 10. This is minus 10. Do we understand this, everyone?
Yes, sir.
All of you got this, or any doubt? There could be one or two doubts to start with. Can I move on to the next question?
Yes, sir, you can.
Here comes the next one, my dear friend. Be careful and tell me your answers. Positive x-axis, you can take positive x-axis as positive, and then that is how we normally use, and then tell me your answers. I'll give you 2 minutes to do that. Are we ready with our answers? Yes or no? So you can write velocity of A with respect to ground is 5 along positive x. So I can write it as plus 5. Do we understand this? Plus indicates this direction. Velocity of B with respect to ground. You may not write ground. You can just write VB. So whenever you write VB, I will understand that it is with respect to ground. Do we understand this? Because if I write G, I will just spend a lot of time in writing G's. Okay, velocity of B with respect to ground will be plus 20, plus indicating that it is in the positive x direction. Now I can simply find out velocity of A. See, find the velocity of B with respect to A. So I was writing it wrongly. Velocity of B with respect to A will be simply velocity of
15,
B
sir.
minus velocity of A. I am just omitting that G so that I save some time. Do you understand this? So I can just subtract it now and I will get plus 15. Yes or no? Yes or
Sir.
no? Now, if I get velocity of B with respect to A as plus 15, is there any need to find out velocity of A with respect to B? But I can straight away say this. Velocity of B with respect to A was plus 15. So velocity of A with respect to B will come as minus 15. Yes or no?
Yes, sir.
Because they both must be opposite of each other. Everyone understands this? Yes or no? No or yes?
Yes, sir.
Are we ready for another question? Have you noted it down, bacha?
Done, sir.
Next question comes now. Two objects A and B are moving with respect to each other with velocities 10 meter per second and 12 meter per second respectively. Find the velocity of A with respect to B. You can always take this direction as positive. Find the velocity of A with respect to B. Find the velocity of B with respect to A. I shall give you a minute to do this. So, have you solved this?
First is 22, sir.
First is
Respect
22.
to B.
Okay. So, how do we do this? I can write velocity of A as plus 10 and I can write velocity of B as minus 12 because it is coming in the opposite direction. Yes or no?
Yes,
So to
sir.
find velocity of A with respect to B, so you have become B. So velocity of A with respect to B will be equal to velocity of A minus velocity of B plus 10 minus of 12, and your answer is plus 22 meter per second. Do we understand this? To get the velocity of B with respect to A, you just do the reverse. Once you have done this, the other thing is pretty simple. Yes or no? Everyone
Yes,
got this? Now, sometimes in your question, you might hear a term and don't get confused with this term. But that term actually is more illustrative. So I'll just show you that term and probably give you a question. Velocity of approach and velocity of separation. Now, what happens is, when do we see or when do we say something? Let us say I'm sitting here or I'm moving. Something is coming closer or something is going away. If the distance between me, I may be at rest, I may be moving. If the distance between or the separation between me and that body is decreasing, I will call it approaching. Yes or no?
Yes, sir.
If the distance between me and the body is increasing, I will call it is going away from me. That is what is known
Separation.
as velocity of approach and velocity of separation. If the separation of the body is decreasing, we call it velocity of approach. If the separation is increasing, we call it velocity of separation. Do we understand this? Now, how does this separation increase or decrease? It increases or decreases by the component of relative velocity with respect to one another. If the component of the velocity with respect to one another, if it is decreasing the distance, we call it velocity of approach. Simply, you can write the separation is decreasing, it is velocity of approach. If the separation is increasing, it is known as velocity of separation. Do we understand this? Now, let us try to make you understand by the same question, but now they have asked it in a different way. Have you noted this down? You just need to note down that separation velocity of approach means when the distance is decreasing. Separation velocity of separation means when the distance is increasing. Do we understand this? Okay, now look at this case. This is the same case that we did just now. Can I move on?
Yes, sir.
Everyone? Don't have to write everything, beta. Please understand. You try just write the important point and write it in your own language. That is more important that you understand it. Don't have to copy everything that you see on the board. Just write in the language that you understand. Shall we move ahead?
Yes, sir.
Okay. Now look at this case. Now, in this case, will we when the balls are moving like this, should we call it velocity of approach or should we call it velocity of separation? Is it velocity of approach or is it velocity of separation? Yes,
It's velocity of approach, sir.
it's velocity of approach because the distance between them is going to increase. Yes or no? It's going to decrease. This is going this way. This is going this way. The distance is going to decrease. We are going to call it velocity of approach. Yes or no?
Yes, sir.
Now look at the other case. Now look at the other case. Let us assume that this ball is moving here along the yellow line. And ball B is still moving along the pink line. Will you call it velocity of separation or will you call it velocity of approach?
Approach.
In that case,
Approach, sir.
we will call it approach. You understand why? Because now B will try to catch it up. Yes or no?
Yes, sir.
Yes, sir.
Okay. Now let me make this to move this way. So this one is moving this way and this one is following it piche se. Will you call it
Approach, sir.
velocity of separation or will you call it velocity of approach?
Velocity of
Separation.
approach.
It will be velocity of separation now because B will keep on going ahead and A will never catch it up. Do we understand this?
Yes, sir.
So
Yes, sir.
it all depends on how the directions are. Do we understand this?
Yes, sir.
Now let us go into the original question and ask you find the velocity of approach. So you can find the velocity of A with respect to B or you can find the velocity of B with respect to A. Do we understand this?
Yes, sir.
So what is the velocity of approach? Velocity of approach will be 22 meter per second. Yes or no?
Yes, sir.
Everyone understands this? It is nothing but the relative velocity. Now let me make the question interesting more. Now let me tell you that the distance between the two bodies at this point is, let us say, 440 meters. Let us say that the distance between the two bodies when this photo is taken is 440 meters. Now, what I want to make you understand is how we use this, not just to find out relative velocity, but how do we take it further. Now, the question that might be asked is, when do they meet? Where do they meet? Now, you can do this question in this way, that you assume that they meet at this point O. Then you say that, okay, this gentleman will move a distance x. This gentleman will move a distance 440 minus x. You can find out the value of x and the time To move x, he has a velocity of 10 meter per second. To move 440 minus x, he has a velocity of 12 meter per second, and they will somehow meet somewhere in between. Yes or no? We can do this way.
Yes, sir.
But if we use the concept of relative velocity, we can do this question very quickly and very smartly. How we can use the concept of relative velocity and do this question in a more smarter way? I'll give you 1 minute to think about it. How can I now use the concept of relative velocity or relative motion and do this problem quickly in a more smarter way? So to do this problem in a quick and a more smarter way using relative velocity, what do? You become any one of those gentlemen. Either you can become A or you can become B. I decide that I have become B. I will become B. So whatever I see will be with respect to B. Do we understand this?
Yes.
I have decided that I have become B. Now, as soon as you become B, remember, you don't go anywhere. Everything comes to you. If you are sitting in a train and suppose you are going from Hyderabad to Trivandrum, you never say, when will the train reach Trivandrum? You will always say, when does Trivandrum come? Trivandrum kab aayega? So basically that is human nature, that when you are in something, you always assume that you are not going anywhere, everything else is coming towards you. As soon as you become B, you don't go anywhere, everything comes towards you. Now, since you have become B, you will see the motion with respect to B. Do you understand this? If you become B, you will see the motion with respect to B. If you want to see the motion with respect to B, you have to find out the velocity of A with respect to B. Yes or no?
Yes, sir.
What is the velocity of A with respect to B? Remember, this direction, I will take it as positive. Do we understand this? This direction is positive. Now, and I will use the plus and minus sign. What will be the velocity of A with respect to B? You can find it out, yes or no? Yes or no? You can find it out. How much is the velocity of A with respect to B?
Plus 22.
Plus and minus are also important. How much is that?
Plus 22, sir.
Plus 22 meter per second. I am not writing unit. Let us now talk about acceleration of A with respect to B. Is there any acceleration? Is A accelerated? No. Is B accelerated? No. So acceleration of A with respect to B becomes?
0.
Now remember, you have become B. You don't go anywhere. You are just there. Now, B is not going to meet A. A is going to come and meet B. What will be the displacement of A with respect to B? Remember, B is not going anywhere. B will remain in this position and A is going to come and meet him. What is the displacement of A with respect to B? How and where should A go to meet B? He must go like this, yes or no, straight away like this. And he will meet B, yes or no?
Yes, sir.
What is the displacement of A with respect to B?
440 meters.
Plus or minus?
Plus.
You know the initial velocity, you know the acceleration is 0, you know the displacement. Can you tell me after how much time they will meet?
20 seconds.
It is 440 divided by 22. Yes or no?
Yes, sir.
So they will meet after 20 seconds. Once you know that they will meet after 20 seconds, you can find out where they meet. Just multiply this 20 seconds by this 10 meter per second, and you will see that A will move 200 meter and B will move 240 meters. Do we understand this? How this question is done? By using the simple approach of relative motion, I have solved the question very simply. Do we understand this?
Yes, sir.
Can I give you a question based on this concept? Yes or no? No, yes.
Yes, sir.
Everyone understands this? Is this question looking simpler this way, or it was simpler in the way original way? He will move x, he will move 440 minus x, then this, then that. I think it is simpler by the concept of relative motion. Yes or no?
Yes, sir.
This comes the next question, and I hope that you can tell me the answer and how do you solve this one. Don't get confused by the language of the question. It is a straightforward question. A particle A is moving with a speed of 10 meter per second towards right. You can see that. Particle B is moving with a speed of 10 meter per second towards right. You can see that. Another particle C is moving with a speed of 10 meter per second towards left. You can see that. The separation between A and B is 100 meters. Find the time interval between C meeting B. So right now C is meeting B. After how much time he will meet A? Do you understand you understand the language of the question? Yes or no? Then I await your answer, my dear friends. I'll give you a minute.
5 seconds.
0 and 5 seconds, sir.
So what is the time interval? 5 minus 0, 0. Do we get this?
Yes, sir.
Pakka?
Yes, sir.
So how should I do this? What I'll do is I will become C. I will become C. So C does not go anywhere. A will come and meet me. Yes or no? So I will find out velocity of A with respect to C. This is plus 10 minus 10. So it will become plus 20. There is no acceleration as such. There is no acceleration as such. How much is the displacement of A with respect to C? Remember, C does not go anywhere. A has to move forward plus 100 meters. Yes or no? From here, you can find out after how much time C or A are going to meet each other. Do we understand this? Or this has gone above our head saying bye bye, I'm going. Don't stop me. Do we understand this?
We understand, sir.
Remember, we are doing relative motion in one dimension. We are dealing with questions of one dimension, and on similar tone, we will do questions of two dimension. Can I give you the next one in the line?
Yes, sir.
I think I should not have given you this because this is not a part of the question, my dear friends. I should have only given you the question, and I will do the same here. Tongue, and I will make this question bang bang, and let us see if you can do this one. I know you can do this one. This is the question. I have forgotten what was the number. I will just call it question number 7. A ball is thrown downwards with a speed of 20 meter per second from the top of a building 150 meter high. Simultaneously means at the same time, another ball is thrown vertically up with a speed of 30 meter per second from the foot of the building. Find the time after which both the balls will meet. Remember, there is no question that you cannot do. The only difference that is going to be real difference is how quickly you can do this. I'll wait for 2 minutes. Yes, bacha, we got the answer. No one? Shall I solve it?
Sir, is time is 3 seconds.
Is time? Oh, I've forgotten the question.
Yes, sir. 3 seconds.
Yes, the time is 3 seconds. Yes, that is correct. How did you get it? That's the question. How did you get it? Anyone who tell me how did you get it? No one? Tell me now. How did you get it? No one would want to say anything. Why?
So 150 by 20 plus 30.
How did you get 150 by 20 plus 30? That is what I wanted to ask. That is correct. See, this is
Yeah.
A, this is B. And the height of this building is how much?
150.
150. Now, you can do this problem in this way, that they will meet at a distance y, this is 150 minus y. You can obviously do it this way. But a better way to do this is by the concept of relative motion. You can choose which body or which ball you want to become. You can either become A or you can become B. I will choose to become A, let us say. If I become A, then what will happen? If I become A, I don't go anywhere. B comes up straight away and meets me. Yes or no?
Yes, sir.
Only B that will move, come up and meet me. If you understand this, then you can tell me what will be the displacement of B with respect to A. I have become A. I will not go anywhere. Remember, that is the concept. You have become A. You will not go anywhere. Only B will come and meet you. What will be the displacement of?
Velocity of B with respect to A into time.
What will be the displacement of B with respect to A? It will be equal to plus 150 meters. Yes or no? B will have
Yes,
to
sir.
come up and meet me. Yes or no? Do we understand this? What is the initial velocity of B with respect to A? Here both the bodies are accelerated. Therefore, I am using initial velocity. What is the initial velocity of B with respect to A? Remember, A was thrown downwards with a speed of 20 and B was thrown up with a speed of 30 meter per second. So it will be plus 30 minus
Minus of
20.
20.
So how much will that be?
50.
Plus 50
Plus
meter
50.
per second. Yes or no?
Yes, sir.
Now the main thing is acceleration of B with respect to A. Now remember, this motion is taking place under gravity. So both of them have same acceleration and that acceleration is downwards and that is equal to G. So it will cancel out. Yes or no?
Yes, sir.
Because acceleration of B with respect to ground is also minus G. Acceleration of A with respect to ground is also minus G. So whenever this motion is happening in gravity, this becomes zero. Yes or no?
Yes, sir.
Because of this becoming zero, this problem becomes very simple. Do we understand this? Now, I can use the formula displacement of B with respect to A will be equal to initial velocity of B with respect to A into T plus half. That thing becomes simply zero. Do we understand this? That gives me the answer straight away. After how much time they are going to meet?
3
150 divided
seconds.
by 50. They are going to meet after 3 seconds. Do we understand this? Do we understand this, or this has gone above our head saying bye bye? Don't stop me, I'm going. You understand this?
Yes, sir.
Yes or no?
Yes, sir.
Can I give you one problem and you solve it for me? Are you confident that you can do this? Confident?
Yes.
I am confident that you can do this. So please take confidence from me and solve this. Tell me the answer and I can say bye bye to this type of questions. A and B are thrown vertically up with velocity 5 meter per second and 10 meter per second respectively. So I'm now throwing two balls up straight away. One with 5 meter per second, the other one with 10 meter per second. G is taken as 10 meter per second square. Find the separation between them after 1 second. Let's see who gives me the answer to this one. Two minutes you shall get. So my dear friends, do you have the answer?
Yes, sir.
What is the answer?
5 meters.
5 meters is absolutely correct, my dear friend. So I draw a very simple diagram. I draw one ball. I draw second ball. This is ball A. This is ball B. I throw this up with 5 meter per second. I throw this up with 10 meter per second. And I will make the question as simple as possible. I will write the initial velocity of A with respect to B. So that will be plus 5 minus plus 10. So that will be minus 5. Yes or no? Do we understand this? You can also find the relative velocity of B with respect to A. Instead of minus 5, it will be plus 5. Do we understand this? Then I can find out the acceleration of A with respect to B. And again, it is going to come as 0 because both are under gravity. Yes or no? Time is given to you as 1 second. So this is there. You have to find the separation between them. So basically, you have to find how much A has moved with respect to B. So you just have to find out the displacement of A with respect to B. Yes or no, my dear friends? That is simply equal to initial velocity of A with respect to B plus T plus whatever there, it is 0. Everything is given to you. You will get minus 5 meters. Minus 5 meters means looking from B, A will be below. Will it be below or not? Yes or no? Because B
Yes,
has
sir.
more velocity, B will be up and A will be just behind B. Do we understand this? Yes or no? No, yes. That is one type of problem in relative motion, where the motion was happening on ground or the motion was happening up and down. The next type of problem in 1D, and from there we can move on to 2D, is river flow problems. River flow in 1D problems. So these problems are also known as upstream, downstream. Do you understand upstream and downstream?
Yes, sir.
Upstream, downstream problem. Upstream, downstream problem. Now, whenever you have, whether it is upstream, downstream problem or any other problem, wherever you have this river boat or river problem, you will have two things that is given to you normally. And we will just note them down. The first thing that is given to you normally is velocity of river with respect to ground. That is one thing that is always given to you. With what speed or with what velocity river is flowing. You can write it as VRG. Normally, we take it as U. Normally, it is taken as U. U does not mean initial velocity. U we are using normally for velocity of river with respect to ground. Do we understand this? Then the second thing that is given is velocity of man or boat, whatever the question be, with respect to, sometimes it is written as river, sometimes it is written as still water, or sometimes it is written as man can swim with a velocity of 5 meters per second in river. Whatever is given, it is always, remember, it is always the velocity of man with respect to river. Will you remember this? Yes or no? No, yes.
Yes, sir.
You can never forget this. So you can write this in this fashion. This will be velocity of man with respect to river, and this is normally taken as V. This is normally taken as V. So U is normally taken as velocity of river with respect to ground, and V is the velocity of man with respect to river. Now, whenever we are swimming in river, we are swimming in river, but the distance that we move is with respect to ground. Yes or no? So it is good that we find out what is the velocity of man with respect to ground. How do I find the velocity of man with respect to ground? I can just, to remember this, you can just put an R here. So you can remember this like this. Velocity of man with respect to river plus velocity of river with respect to ground. Do we understand this?
Yes, sir.
This is another way of writing the same thing. If I just bring this gentleman on this side, this becomes velocity of man with respect to river. Yes or no? So I've written the same equation in a different way. Do we understand this?
Yes, sir.
Now, remember, whether it's a question of upstream or it's a question of downstream, this equation that I have written is always valid. Do we understand this? Because this is a vector equation, it is always valid. Yes or no? No, yes?
Yes, sir.
Okay. But when we talk about upstream, downstream problem, we are talking about problem in one dimension. Now, in one dimension, if he is moving downstream, his velocity with respect to river and the velocity of man with respect to river and velocity of river, they will get added. Yes or no? When he's moving
Yes, sir.
upstream, his velocity will get subtracted because this is coming from here and this is coming from here. Yes or no? No, yes. So in that case, and I will just show you both the cases together to save some time. This is how the situation will look like. If he is moving downstream, dung 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 like this, his velocity with respect to river, that is u, and his velocity and velocity of river will get added up. They've interchanged the velocity. So velocity of river is taken as u. Oh, no, see, velocity of river is taken as u and velocity of man with respect to river is taken as v. Both are in the same direction. So the velocity of man with respect to river, man with respect to ground becomes u plus v. Do we understand this, my dear friends? Similarly, when he is moving upstream, you can see the river is flowing like this. Here, river was flowing like this. The gentleman was moving like this. Here it is opposite. And therefore, his velocity with respect to ground becomes v minus u. Do we understand this? Yes or no? No or yes?
Yes, sir.
Have you noted it down, my dear friends? Yes or no? No, yes. Array, have you noted it down? Huh? No. What are you doing?
Done, sir.
Done, sir. Can I give you a simple problem, sir, for the class and wind up this class?
Yes, sir.
And my dear friends, here comes a straightforward, simple problem. Based on this, I have forgotten the numbering, so I'll call it problem number 1 again. A swimmer capable of swimming with velocity v relative to water. Do you understand? This is the velocity of man with respect to water. Yes or no? Are you understand this? Jumps
Yes,
in
sir.
a river. Why does it jump in a river? In a flowing river having velocity you don't do this stunt because the velocity of river is too more. You will just drown. Don't do this. This is just for the question. The man swims a distance d downstream and returns back means upstream to the original position. Find the time taken in the complete journey. You will have 2 minutes to solve this for me. Time taken for the entire journey. He first swims, reaches that point, turns back, goes to the original position. How much time does it take, my dear friends? Total time. Yes, tell me. Total time. This will be equal to time taken downstream plus time taken upstream. Yes or no?
Yes, sir.
How will I find the time taken downstream? There is no acceleration. So displacement is u into t plus half a t square is gone. So how much time will it take to move downstream? How much distance it travels? How much is its displacement? Do you see this? Yes or no? So how much will be the time for downstream? It will be d divided by v plus u. Yes or no?
Yes, sir.
How much will be the time when it takes to move the same distance but upstream? It will be d upon v minus u. Yes or no?
E minus Q. Yes.
You add these two terms, I think you will get 2 times dv upon v square minus u square. That is the answer for this particular question. Do we understand this?
Yes, sir.
I hope everyone has noted this question down.
Done, sir.
Well, then this brings us to an end for this session of relative motion. We have made good progress and we were able to complete relative motion in 1 dimension. In the next class, we will move ahead and do the same thing, but now
2
in
dimension.
2 dimension, and nothing will change. Equations are same. The motion just becomes a bit more. It is simple only. It is not complicated even. But again, complication is only in our heads. If we can keep things as simple as they are, they would look as simple as they should be. So I'll meet you in the next class and try to wind up this relative motion in 2 dimensions by the next class, so that from the next to next class we might move further ahead in life. If you have any doubts, please ask. Else is a wrap from my end. Take care and God bless you all.
Thank you, sir.
And